Welcome back to Harburn Double. I've made up a little harness to go from the 4-channel relay into the DCC next, and also the power supply, which will be 12 volts. So I'll plug this in, wire it in, let you see it, and then we'll move across to the computer and we'll show you how to program in the relays as an accessory. Well, that's the signals all wired in, and it's connected also to the 12 volt bus system to power the 4-channel relay. All you do is I plug in the USB, switch on the power, jump across the computer. I'll explain to you a couple of ways how to wire up signals, and then I'll show you how I did this one. And then we'll jump into the DCC program, or the Marduk program I should say, and we'll program in the 4 signals. This is one of the ways I wire up some of my signals on Harburn Double Low. Basically, you're using this relay as a switch. Goes one way, a red light will be on, goes the other way, a green light will be on. And if you wire up your LEDs, you can either use a common positive or common negative. This is another way you can use the DCC decoder. This time you're using 2 ports for each individual light. And with the DCC Next, the cool thing about it is you can actually set it up as a pulse width modulation, so you can get a bit of fade into your lights rather than being on or off. The same again, you've got common negative, or you can go for a common positive. This is one of the designs from Alistair Fitchie, one of my Merg friends. It's basically a high-low circuit. So if your DCC to port is high or low, I'll switch the LED from red to green. With the current setup on the DCC, this is what I use here. Now I did say in the last video there, I put in 2.8 volts for the buck converter. It's actually 2.2 volts. The LED would light for a short time with 2.8 volts, but not for much longer. So basically the DCC port goes high or low. This is power supplied by either 12 volts or 5 volts, depends on the voltage of your LED, your relays. And when the port goes high or low, I'll switch the LEDs on. And the same again, you can have a common negative or a common positive with them. Just a wee note on the LEDs there. I'm using red, it's between 1.8 to 2.1. 2.2 is not a big crisis for it. And the yellow ones is 1.9 to 2.2. What you need to watch out for, you got the greens from 2 volts to 3.1 volts. Therefore, if you're using a common buck converter, putting 3.1 volts in it, your red LED wouldn't last too long. We'll do the first one, SG1. Now, I press P for program, and number 11 is the first one. It's going to be port 11 for signal number 1. And the address for it is address number 4. Now it gives us a choice. The last time we done servos, this time we want to do is an accessory A. And if you want to see what types of accessories you can set up, press 0. So you can have a signal steady state, a signal flashing light, a double steady state, a double flashing light, a single one shot, a double one shot, an analog pulse wave modulation, a flicker, i.e. a lamp flickering. And number 9 is just for a random on off, i.e. if you've got an office block and you want to turn the lights on and off randomly, you'd use number 9. On the pulse width modulation, it only works on certain pins on the DCC Next, and it is very handy for fading and So we're going to go for a single steady state, number 1. So we'll now set it there, and we're now going to save it. So we press E. That's it. Well folks, that's a complete. Very smooth, very good bit of kit to install as well. The only glitch I had was this back key relays, the 12 volt power supply ones. I have got common ground on my 12 volt and 5 volt bus, and normally with the Arduino there, 5 volt is the high and 0 volts the low. This just would not switch with the 5 volts, so I end up having to change the board to another board, be a 5 volt one. Hope you've enjoyed it. I hope it's given you some ideas as well for your own layout. So thanks for watching folks. Bye.